After the steel has been produced, every piece of steel in a skyscraper or bridge must be precisely cut, its holes properly placed, its pieces welded in exactly the right location. Every single bolt in the structure must be located and attached at the proper place, and all this must be exact to 1/16 of an inch, so that the steel members will fit together perfectly at the site. That's why a process called detailing is such an important and integral part of building today's complex steel-based structures. It is the detailer who must develop drawings that are so precise that they will show the fabricator the exact dimensions required for manufacturing the finished steel components that will go into the structure. To accomplish this formidable task, the detailer will take the design prepared by the structural engineer and, on paper, build a 2-dimension or a 3D model of the steel frame of the building or bridge. It is from this model that the detailer will generate a complete list of every member in the structure, as well as shop drawings for all the individual steel pieces. To accomplish this process, the detailer must compute the length of the beams and columns, as well as the bolts and raw material to be used. The detailer must also keep track of every hole in the entire structure. If a change is made in a beam connection or in the hole of one column web, it will be up to the detailer to indicate exactly how that change will affect all the holes in those beams. In addition, if a member has been changed on the shop drawing, the detailer must also change the erection drawings that will be used in the field. All this information is developed with the help of computers, and it can be downloaded to the drill line in the shop or to the angle master to show them how to drill holes for the angles. But it's important to realize that although these critical tasks are done with the assistance of a computer, they are not done by the computer. The detailer's training, skill, and expertise is the key to the process. It is the detailer's ability to translate the engineering drawings of a large structure for the fabricator so that the fabrication shop will know exactly what must be done to prepare the steel. The detailer will also indicate the preparation, cleaning, and painting of the materials, depending on its specification. If that weren't enough, the detailer may also have to consider and take into account shipping requirements, sometimes even the cranes that will be used in the field, and how those cranes will load and unload members from the truck. Before the fabrication shop actually drills and cuts the steel members, the detailer must submit his shop drawings to the engineer of record for approval to make sure that the shop drawings are fully compliant with the engineer's design. It's clear that steel fabrication plays an important role in joining steel members, even before the beams and girders arrive at the construction site. This is one reason why on-site building with steel is so much faster than is possible with other materials. At the fabrication shop, the steel is cut, punched, and pre-assembled as much as possible, according to the detailer's drawings. These drawings can be used to generate computer disks that will drive the shop's fabricating machinery to cut and drill the steel with absolute precision. If cutting is necessary, the operator inputs the size and the desired length of the member. The stock lengths of steel will enter the cutting machine by conveyor. An automatic arm stops the stock at exactly the right point, and the blade cuts the steel. The piece will then be labeled and rolled out. From the cutting area, the steel members will travel on a conveyor to the next station, where holes will be drilled to make the bolted connections. Here again, these critical processes are precision controlled by computers.